discuss about migration process from legacy infrastructure to the SD-WAN enabled on SSE enabled infrastructure, that is your SASE architecture, right? So just to give you an overview about the LPNS, you already know how it works and all that stuff, right? So I'll not go in deep, but yeah, definitely we can have an overview that your offices, branches, they all are connected to data center DCDR to MPLS cloud, right? You get this MPLS cloud from ISP providers within your country, right? And for remote users, we have this VPN concentrators, VPN gateways in the data center, which are going to facilitate the RA VPN connections, right, for the remote users. So the only problem here is like we don't give local internet breakout to branches, right? And now all the SaaS applications, they are moving to cloud. It becomes a bottleneck if you forward the entire traffic towards the data center, and from there, if you break out to your on-premise resources, to your internet resources, or to your SaaS applications, wherever you are sending it. So to avoid this bottleneck, what we have, it's like local internet breakout, or you can say direct internet access through branches, right? And instead of MPLS, because in the cost of MPLS, you can buy ILL, internet lease line plus broadband links. And this is the most adopted combination of underlay these days within the organizations now, right? So everyone is transforming and they are planning to transform their underlay network from costly MPLS solution to ILL plus broadband or broadband to broadband, right? If I will give you an example, 100 Mbps MPLS link is going to cost you somewhere around 5 to 6 lakhs yearly, right? On the other hand, if you go with the 1 Gbps broadband, right, it is going to cost you somewhere around enterprise grade broadband where contention ratio is, 6 is to 4 or 5 is to 5, right? So if you go with that, that contention ratio, so it is going to cost you somewhere around 70,000 rupees, something like that, INR. Right? This is the best, enterprise grade broadband line. So now you can imagine in 100 Mbps of MPLS, you were paying 5 to 6 lakhs, the same cost, not in the same cost. Less than that, you get one broadband link, right? And you can in fact get 100 Mbps ILL at 2.8 lakhs. Okay. So if you do the cost comparison, it is turning out to be 3.5 lakhs, and you are getting huge bandwidth, huge, because this will come with the contention, but this will be 1:1, 100 upload, 100 download, right? And here, if your contention ratio is 1:8, or let's take an example, 1:, worst case, 1:8 contention you're getting here. But still, if you club both the bandwidths with the help of the SD-WAN router, you'll get something which is larger than this, which you are getting for this amount, right? So here you can see that we have reduced the amount by half, and then simply, you can also accommodate SD-WAN router in this remaining amount. So this is how we do transformation for the, you know, uh, enterprises, right? We give them the cost comparison, and then we give them the feature comparison, right? Because here, if you will see, everything is centralized. Backhauling is done for the traffic. And if you go with the decentralized architecture where local internet breakout should be provided, so in that case, you will get efficiency in the applications, especially your SaaS applications and your public cloud hosted applications. So this is an overview why transformations are happening for the enterprises globally. And when you do this transformation globally, you will see better returns, right? So everyone is concerned about the ROI and the POC, involved in these transformations, right? Now, what do we get inside Prisma SD-WAN? What features we have, right? In our own devices and all that. So the very good feature in ION devices, it's like you get end-to-end segmentation with VRF, right? So it's like here you have overlapping subnet, here you have overlapping subnet, and we know that overlapping subnets, they create problems, right? But the difference here is like, the overlapping subnet on this remote side is overlapping with the IT network. Here it is overlapping with the IoT network, right? So we have VRF created on different subnets, right? So you have B2B communication, branch to branch communication, right? And you have branch to DC communication, right? And it is segregated with the help of the VRFs, right? So this is your green VRF, this is your yellow VRF, and this is your traffic flow, how we are doing it. So it's the same concept, but we used to get it inside the MPLS, right? So any ISP, they build their network, they build their MPLS network, and then with the help of the VRF, they segregate the customer, traffic from one another, right? So if I talk about more on SD-WAN architecture, especially Prisma, right? Because when we are planning our SASE transformation from legacy MPLS to SASE enabled, right? You cannot do it everything in just one go. Best recommended ways like first roll out SD-WAN on the branch devices and then connect your SAC, right? So first, what we are going to do is we are going to roll out the SD-WAN devices, right, on the branches, because here the physical devices needs to be shipped to the branch. Zero touch provisioning is there, where you can make the branch live in just few seconds, right? So these routers will be supplied. Underlays will be terminated on these routers, MPLS, cellular, broadband, ILL, whatever underlay you have, right? Because for few you can say organizations, it is mandatory to have MPLS link. If I give you an example of Indian customers, Indian call centers, right? If they want Teams call to get connected with the PSTN network, it is mandatory for you to have MPLS circuits, right? Because as per the DOT guidelines, you cannot land the PSTN call over internet network, right? You have to have a private connectivity for that. This is in India. In abroad, it is allowed. So it depends on country to country. Accordingly, we design the solution. So your migration process will start with SD-WAN first, right? Because this will be becoming traffic forwarding method from your branches. So we need to first onboard these circuits, new lines, right? Your parallel setup will be there. This parallel setup right above here. It is going to work the way it is working. Parallelly, we are going to build this setup, right? We will give new circuits, new routers, right? And then we will try to connect them with the data center. So your SD-WAN journey starts with the data center, because it's like we will be building hub and spoke architecture, right? Or dual hub architecture. So you need to first transform your data center. You need to put the devices here, and then only you will start onboarding your branches and you will be building your SD-WAN fabric. And that process you can, create the template and you can make it very fast. So this is how it is done. So in migration approach, first we will transform the data center. We will put SD-WAN boxes there. We'll onboard the new lines. Then we will start with one or two branches. We'll connect them with the data center. We'll do the pilot testing and all that. Once it is done, then we will be connecting it with the Prisma Access service, so that we can get the security posture from the cloud. So your next step will be like once it is done. So here it is. This is how it is going to look like, right? The overall architecture where you have the device on branch. This is your IO instant on device, right? So this is the device on branch where it is having connectivity with the Prisma Access Cloud with the help of the IPsec tunnels, and it is also having connectivity with the data center, direct connectivity. So in this case, in this architecture, you can avoid SCCAN, which we were discussing. I mean, we can have SCCAN for MUSPN, I mean, for mobile users, but for remote network, that communication can be avoided because you will be having direct connectivity from this device towards your data center device, right? So this is the benefit you get from Prisma. That I mean, not from Prisma, it's from every SD-WAN vendor that you have the direct fabric connectivity from your branch to DC. And for branch to DC communication, you need not to send your packets towards the SSE. Only internet and SaaS based traffic will go towards the SSE, right? So this we can do. So your controller messages are going to come from CSM, Cloud Strata Manager, to manage these devices, and your logs and Prisma Access logs will be centralizedly collected on Strata Logging Service (SLS). This is your Cortex data lake, right? So there, everything will be stored, and then you can also stream down these logs to your any on-premise solution or anywhere you want, right? So this is how you're going to be, transforming the enterprise network step by step, and you have to give this a prepare this approach, prepare the documents accordingly, and share it with your customers. Now, if I will show you a very good feature from Palo Alto, it's like autonomous digital endpoint monitoring, ADEM. Right? Why do we need ADEM? You see, industry is inclining towards digital endpoint monitoring, right? Because these days, when you're switching to cloud-based services, it is becoming important to understand, the packet flow hop by hop, because now you're not limited to a single topology within your branch or data center. It's like there are so many services which are coming into the picture, and that too cloud services are coming into the picture. Now we need a service to keep track of this path which your packets are taking, right? So this is where digital endpoint monitoring is also coming into the picture to keep track of your applications, of your user, right? So that when any user is facing problem, any application is facing problem, we can track it very easily. We can isolate the problem very easily. We can identify it that, throughout this path, where could be the problem? Okay. So these are the things which you can help. I mean, you can get the insights with the help of the ADEM, right? It is similar to ZDX, Digital Experience Monitoring Platform from Zscaler. Similar grounds, they have also provided you the ADEM. Now coming to this user ID feature. So Palo Alto has also given you one interesting service. It is Cloud Identity Engine. So it's like you will be having Active Directory, right? You will be having your user IDs created on Okta or any IDP provider, where whatever it is, right? So what Palo Alto says that you can connect these to the Cloud Identity Engine. You can onboard your users, you can onboard your groups to the Cloud Identity Engine, and then you can make use of these things inside your policies. You can make use of it inside your SD-WAN. You can make use of it inside your Prisma Access policies. In both services, you can make use of this. So why we are integrating everything in this one cloud identity engine? The reason is like, we have Prisma SD-WAN, we have Prisma Access, right? So like in Zscaler, we have to do the integration on different services. So this is what they have isolated with the help of this service, that this is my identity engine where you can bring down your users and groups, and that information I'll cascade it to all my services, cloud services, be it SD-WAN or be it Access, right? So that you need not to worry about your users and group again and again, right? So this is what it is. And this is very good service. We will explore it, right? So for this, you need not to pay anything, right? It's like you get it when you buy the subscription. So it will help you to, bring your user groups in one point and get it synchronized across your services, whatever services you get from the Prisma Access and Prisma SD-WAN subscriptions, and then create your policies as per the user ID or group IDs. This is very interesting feature from Palo Alto. So when we plan out the migration, what we need to keep in our mind, it's like, because you're transforming the underlay network, you will be doing complete transformation of the customer environment, right? And the infrastructure is very, very big. Okay. So if I will give you an example, let's take an example. Customer is having 100 branches across globe, right? So there, how you're going to expedite this transformation journey, right? Because if you're going to, you know, do some sort of, architectural flaw or something like that during this transformation journey, customer can have severe impact. So that's why proper designing and planning is required before you propose a solution to the customer, before you propose an architecture to the customer, right? Because when we talk about SASE architecture transformation, your underlays will be getting transformed, your edge devices will be getting transformed, your entire security posture is getting transformed, right? And there will be possibility that you need to migrate your policies from on-prem solutions to the cloud-based solution, that is Prisma Access, right? Or you might need to create your security policies again, right? So it is going to be big transformation. It is not that easy to do it in just 1 or 2 months. It takes time. It depends on the customer landscape. And obviously, whosoever is going over SASE, it means that they have a good infrastructure. Because for small enterprises, SASE makes no sense, right? They are only good with SD-WAN, and whatever features they want, they get it through the SD-WAN boxes like Fortinet SD-WAN they can take, or any other, you know, affordable solution they can take, and they can get all the services. But on the other hand, if we have a big organization where we have so many employees, let's take an example, 50,000 employees and 100 plus locations. For such customers, this transformation is very big. Okay. We need concrete project plan. We need migration approach. We need to first analyze the current infrastructure, the application landscape, the bandwidth sizing on each location, right? Current throughput of the data centers, underlay throughputs, right? Everything we have to monitor, we have to analyze, and then accordingly we will be doing sizing of the SD-WAN edge devices, right? And the security, cloud security service sizing. We'll do it as per the number of users and bandwidth involved, right? Once you have this information with you, accordingly, you will prepare the BOQ, you give it to the customer will review it, right? And then you will get the sign off on your proposed solution. And then comes the main part, it's like architecture, right? How you're going to plan out now, because you're switching to internet. And we all know that MPLS being expensive, you get control, latency, jitter, packet loss, right? And chances of going any link down is very less. But in internet, it's like, anytime you can have outage in the lease lines or broadband links or RF, whatever it is, right? So when you're switching from reliable network to unreliable network, you're also increasing risk. So to mitigate that risk, what do we have? We have to propose, we have to identify the critical locations, we have to propose the, high availability architecture of the SD-WAN devices, whether we have to run it in active mode, we have to run it in active passive, how we would like to do the load balancing on the underlays, whether we have to make it active passive, right? And whether I want my business applications to travel through internet lease line and my SaaS applications and other traffic should go via broadband lines, right? So these are the decisions which we normally do with customers. We organize the LLD workshops, gather their inputs, right? And then organize this piece of information in a way that it can suffice the customer use cases when we are giving them the new solution, and it can help them to transform their end-to-end journey, because this WAN transformation is very critical. Reason being that when you do land transformation, then the story is on a different side. Your impacted branch will be one or two when you're doing land transformation, right? But when you're doing WAN transformation, if something goes wrong, you know, the impact could be bigger. Okay, so this is how WAN transformation are critical, and we have to be very cautious when we are designing the overall solution. Your traffic flow pattern should be crystal clear, that where your packets will be flowing. What are your business critical applications? What are your non-business critical applications? Your marketing applications, your SaaS applications. And accordingly, we define the cost on the links, and we design the traffic flow, right? So this is how we plan out the migration from legacy network to SASE based network. Any doubt, anyone?